Hey there, physics fans. Today we're going to talk about how to draw a free space diagram when we're dealing with electric fields between multiple particles. And so in order to do this, we're going to utilize text problem 5-116. So if you pull it up, you'll see that there's a configuration of 3 charged particles. So in the bottom left hand side of this square is 1 positively charged particle. Now, positive charges have an electric field that always points away from them. In the top left-hand side, you have 2 times Q, so almost like a double negative charge. And negative charges always have electric fields pointing towards them. And then on the top right-hand side of this square, we have another positive charge. So again, positive charges have electric fields pointing away. And the problem asks, what's the electric field at the lower right-hand corner of the square shown below? So that's where, at this point P, where this yellow dot is, what is the electric field that this point experiences? There's no charge there. It's just we want to know how much electric field could you measure at this particular point of the square. So I've utilized the PhET simulation to help give us a nice visual. And then I'm going to draw that free space diagram sketch. All right, let's go, physics fans. So we just finished up our PhET simulation for text problem 5-116. And now we're going to go and actually work on that free space diagram. So to start off, we need to do some labeling on this square configuration. I'm going to first label our point of interest, P, down in the bottom right-hand corner. That's where there are no charged particles, but that there is definitely an electric field being felt at this particular location. And then I'm just going to label each of our charged particle locations. So we got 1, the upper right-hand one is going to be 2, and then the bottom left-hand location, we'll just call that 3. So we got 1, 2, and 3. So in the first step in the free space diagram, it's very similar to a free body diagram, where instead of isolating a body, I'm going to just isolate that point of interest. So that's what I'm going to label, is point of interest P. The second step is let's label all those electric fields that can be felt at that particular location. Well, let's look at our, we'll start with the electric field being felt from charged particle 2. From 1. So that's where there's 2 negative charges, Q, at the top left-hand corner at location 1. So negative charges always have electric field lines that point towards them. So from point P, it's going to feel an electric charge all the way up towards that first location. So in my free space diagram, that's what I'm going to draw. I'm going to draw an electric field, label it 1, and it's pointing up and towards the left. Next, I'm going to look at charge 2. Well, the second location for that charge, the top right-hand corner, that charge is positive, so its electric field always points away. So in my free space diagram, I'm going to draw a line where there's an electric field coming from that charge in the upper right-hand corner, which we labeled 2, and that's pointing downward. And then finally, I'm going to label the third location. That's another positive charge. So again, it's pointing away. The electric field from that charge is pointing away. So over at our point of interest, there must be an electric field that is pointing away, and we call that the electric field from 3, meaning the location that we labeled. All right, so now we need to draw coordinate axes. So again, this is very similar to our free body diagram, so we need to label X and Y, positive X and positive Y. And then we're going to label our critical angles. And so the only electric field that does not go only in the X or only in the Y direction is the electric field coming from 1, from that location where there are 2 negative charges. and that is some angle away from the vertical. And we'll call that theta. And that's a critical angle that we would have to solve for this problem. All right, physics fans, now we have a nice free space diagram. We're ready to continue solving this problem. So remember, free space diagrams, very similar to free body diagrams, except instead of forces, we're dealing with electric fields. And instead of forces acting on a body, we're dealing with the summation of all those electric fields, helping us visualize what's happening at a certain location where there isn't a actual charged particle. All right, good luck, physics fans. You got this.